Okay, problem 79, I'm looking at it. The numbers are kind of big to me. I want to kind of make them a little bit more manageable by factor them. So I'm going to put down 1058, and certainly it breaks. I'm going to say 2, and that would be, let's take, that's going to be 529. And 529 also breaks into two numbers, 23 and 23. Let me just go through that in the side. I'm going to erase my baby arithmetic later. 3 times 3 is 9. 3 times 2 is 6. 2 times 3 is 6. And 2 times 2 is 4. That's 9. 6 and 6 is 12. And you get 529. So this is kind of good news because the square root of 1058 is going to be 23 root 2's. So I'm going to write that down. And the root of 1058 is going to be 23 root 2, all right? I'm going to get my eraser out and get rid of this stuff over here and this stuff over here. I don't need it anymore. And I'm going to do the other number, which is 896. A little more challenging, though. So 896. And I definitely see a 2. That's going to be 448. All right, I see another 2. So it's going to be 2. And that's going to be 224. I see another 2. And what's it going to be? 2112. Now, by the way, you could go on further, but I'm kind of comfortable now that I could write down a little bit simpler with the understanding that I'm looking for something, all right? And I'm going to write down minus, well, I definitely see 2, because the square root of 2 is 2. I see a root of a 2, and I see a root of 112. Now, granted, I'm not saying you can't break this down. This breaks down into 2, and that would be 56. You certainly get another 2, and what would that give you? Well, that's going to give you 28. You get the idea. I could keep going on. Now, someone says, why'd you stop there? I wanted to see a common factor between the two terms, and I wanted the coefficient to be a 2. We've been doing this for a while now. So I'm going to write this down now as the root of 2 times something. And what's going to be 23 minus 2 root 112. All right, let me get my eraser out. And again, I want to remind you, we wanted this form. What's the form going to be? You know, a 2 in front of some kind of root. And why is that? We're now going to take the square root of this thing. All right? So we're taking the square root of this thing. Well, we've been doing this for some time. What's that going to be? The square root of 2, square root of 2. And then I get the square root, which is what I need to denest now. And I'll write it down for you. And what am I writing down for you? I'm trying to denest to 23 minus 2 root 112. And I'm going to say, I think I can do it. Square both sides. You get a plus b minus 2 root ab. I equate things that look good together. For example, 23, if things are nice, should be a plus b. And 112 should be ab. I'm going to start to factor the 112 in two numbers. And the first numbers I'd put down are 2, and you get 56. The next two numbers I put down are going to be 4 and 28. The next two numbers I'm going to put down are going to be, I gotta make sure I'm doing this right though. 2 times 56 is 112. Yep. Did I do that right? 25. Yep, 28. And let me take a look at this over here. And I'm going to put 8 and 14. And then I'm going to put 16 and 7. All right, I'm not looking for combinations, by the way, just like you've done when you factored problems before. And I'm going to say this is very promising because 16 times 7 is 112, and 16 plus 7 is 23. So I think I have it denested, and I got to be very careful about here. So it's got to be the root of 16 first, and then minus the root of 7. That's going to be 4 minus root 7. So I think I have it. This will be the fourth root of 2. And then the denested root over here is going to be 4 minus the root of 7. I'm going to commit to this answer over here. I'm going to get my red pen out. And I want to see if I got the answer in the K. I got to look for it, right? And it's right over here. It's the fourth root of 2, 4 minus the root of 7. Not bad. We did okay with that. Is this a tougher problem? Yeah. It's the numbers that throw people, all right? They're designed to work, though. I can't say it enough times. They're designed to work. Thank you.